Hello and welcome to the Motor Doc Podcast, episode 32. Fallen behind just a little bit again. It almost seems like I've fallen to an every other week for a couple of reasons. One is I've been interviewed quite a bit by other podcasts. There'll be another one out this week that has a viewership of about 1 million. So that one will be on Wind. That'll be in the newsletter. If you haven't signed up for the newsletter yet, go to motordocai.io or motordoc.com and go down and sign up. You should receive a confirmation email that you want to be added, and then there you go. So one of the things, the other thing is a lot of conferences. So this last week alone, starting last Saturday, I drove up to Minnesota where we had the electrical installation conference. I had a couple of papers that I was in, one I wrote, one I was involved in, one on dissection of generators and components, and the other one was a joint paper on IEEE 117, which is more about the aging properties of electrical installation system and the whole history behind that. And I did a little bit of research, as a matter of fact, a combination of things. IEEE Explore, and believe it or not, I used ChatGPT, which is our topic today. As a matter of fact, what I'm going to do today is I'm going to walk you through a little bit, step by step, on how to use it as an assistant. Now, I got up there Saturday because Sunday I wanted to sit in a class on AI, and machine learning used for engineering, and really, in particular, electric machines. It was more, my critique is it was more a class on how machine learning works rather than applications. So I'm going to focus on applications, especially for ones like this. So this will be, I don't know how long this one's going to be. I didn't plan it out. I just know I have a couple of subjects I want to cover. First one is going to be kind of a walkthrough on how to approach, in this case we're going to use ChatGPT 4.0. It'll give me a chance to show off some of the new features that are here. I've had some flash reviews of some of the other stuff that's coming up, being an early adopter. And I'm going to walk you through some ways and means to avoid some of the problems that are often attributed to this platform. Now, there's a variety of things like Copilot for Microsoft, Copilot for programmers. I use all kinds of AI tools primarily to help with productivity. Now, does that mean that I have it do all the work? Well, absolutely not. But I can take using it as an assistant and take weeks worth of work and condense them down to a half a day. I've been doing a series, for instance, on the air gap magnetic fields and how you can look at the entire system with electrical signature analysis. And it's a little math heavy, so I went ahead and used versions of ChatGPT 4.0 to assist me with that. But I had to double check everything. I had to fix the wording and everything else. So while I won't claim that they're 100% my article, because I did utilize ChatGPT, it was quite interesting, an experiment, and that's exactly what it was. It also identified a few things, and one of the most important parts was that the tone, the writing tone, was very obviously not me. So there's keywords and stuff like that show up. So having practiced that, part of the reason I did that was to alleviate my concerns having to do with submitted papers that I do for peer review. Looking at those and saying, okay, now I know this is AI generated and here's why. Or I know this and that. What I did actually do is I had it help me find research papers with the formulas that I was looking for. It helped me identify some of the algorithms that I wouldn't have otherwise have thought to. I would have spent hours looking through textbooks, basically. and reference books. It helped me with all of that. We're going to go through some of that first, and then second, we're going to go through a reliability application using machine learning through ChatGPT for a root cause failure analysis. But the first step is understanding and learning how to use it properly. And I'll tell you something, if people are having to go to school to learn how to do prompt engineering, there's some issues there. I can see programmers learning how to do certain things with it, but it's evolving so fast. ChatGPT 3.5 was a leap forward in all kinds of things. 4 left it behind. I mean, I don't know how many thousands of times more powerful it was. And then finally now 4.0, which is the stepping stone between 4 and 5, is faster. The accuracy seems to be better, but again, anything having to do with AI, I have to say, don't trust and verify. That's don't trust and verify. So basically, know that it's going to throw hallucinations at you and everything else. If something, when you read through it, you have to understand the topic. While it's good for research, if I'm going in and I'm working on magnetic field strengths having to do with electrical signature analysis and current signature analysis and how that all works for this type of defect and that type of defect, I have to understand my topic before I use it. If you go back to the papers that I wrote, you will notice that it's going to give you a single peak instead of peak pairs in some of the formulas. I left those in there deliberately to see who would comment. So there's a lot of things that are pro and anti with it. But if used properly, like what we do, you can save a lot of time and a lot of energy. It's just a different approach to working. I look at it kind of as like a super advanced web search tool, because one of the things you have to remember is with all of these AI tools, to date, it's not saying that eventually it might do something different, because I did not expect it to do some of the things that it does do. One, by the way, is the algorithms and the methodologies are no different than they've ever been for machine learning or AI, or what we're now calling AI, that we now call AGI. But AGI is going to become a marketing term, and they'll come up with some, I think it's ASI or artificial superintelligence. But it still comes down to something very simple. Even the people that create this stuff don't quite understand it, and they have to do things to trick it to do what they want it to do. And as a result, like right now, it's early in the day, I'm expecting it to be relatively accurate. It's about 9 a.m. By about noon, it's going to be pretty bad, and after lunch, I'm not going to bother using it. And then tomorrow morning, I can get up and start the whole cycle over again. And there's all kinds of reasons for that. But I digress, and I've taken 9 minutes to just do a quick intro. So let's go ahead, and we're going to take some data. We're going to take some ESA data, and we're going to take it in, and we're going to manipulate it a little bit. So it's real data off of, it's off a wind turbine. I'm in the process of analyzing. But let's go ahead, and and I don't use this for analyzing wind turbines. It's not that accurate. But let's go ahead. We're going to bring in some raw data, and we're going to manipulate it. Now, I also have to understand certain things about it. But let's go ahead, and we're going to do it. And what I'm going to do is what I did to learn the ChatGPT platform, and that is I'm going to walk through step by step. Then we're going to, once we learn that, then we're going to come up and look at some of this other capability like this, Ask Your PDF Research Assistant. There's all kinds of tools they built in to improve your accuracy, plus allow you to hunt for stuff. So I'm going to come in here and say, okay, let's go ahead, and we're going to go straight to uploading a CSV file. We want to do a CSV file. Let's go here in podcast data, and where's the one that I just uploaded? Here's the one. So I'm going to use high frequency data set because that's about 9 seconds in length, and at 12 kilohertz. So we're going to open that up, and I know that, but I want to get this up, and I'm going to do a function. I'm just going to import the CSV. So there, it's uploaded. So I'm going to type in import CSV show. Well, I don't technically have to have it show the headers, but let's go ahead. We're going to do it anyways. So we're going to see what the channels are and everything else there. So you notice, now I have this turned on, so it'll show me what it's doing. It's using Python. Up here, this is new. What it's doing is it's uploading. You note I can download again the thing once I do certain things, but it's uploading it. And right now, I can see the whole thing. Okay, so here, this is something else, and it'll allow me to come in and do things with it. Okay, so there it's popping up column and stuff like that. I don't want to do that, so it's going to get rid of this. But so it's come in and said, okay, here's my headers. I got TX1000. What is this? Well, that is my time in milliseconds, or 1,000ths of a second. So each of these is an extra, 3 zeros. Okay, so I'm going to do a couple of things now with it. So channel 1, 2, 3, 4, 5, 6. Well, I know amperage, voltage, amperage, voltage, amperage, voltage. 7 and 8 are for my accelerometer in the device. 9 and 10 are not used. 11 is in kilowatts. And then really not much down here. So for fun, we're just going to look at current only. So we're going to look at channel 1. So what I want to do is remove all columns except for channel 1. Oh, there's something else I need to do because I understand what happens when I import a CSV with Python. So I'm going to say remove all spaces in headers. Okay, notice I'm doing this one step at a time. However, I'm going to skip one just because I'm going to have so many times I can operate this. So remove all spaces from headers. Keep only columns including TX1000 and channel 1. And I'm going to drop all the other channels, basically. In the, so this is, let's see, is it a pandas? Did it do a pandas? No, it just imported the CSV. So, in the data frame, which is basically it's going to switch it over. I think it's supposed to switch it over. I don't know. Here's what's fun is one time I go and I sit in a class and this guy is talking about ChatGPT and how to use it for this, that, and the other thing. And he went in there expecting it to act the same way it had when he practiced his talk that morning. But it did not. Okay, it is using pandas. So now it's taking that CSV and it's creating it's creating what I asked for. Okay, so then it's filtered it, and there we go. So it's now channel 1 and TX1000. It has removed the spaces, so it's let me know that. Okay, so now change the header TX1000 to time. Okay. The time is in let's see, the time is in milliseconds. Okay, the time is in milliseconds. Got it. So let's see what it does. Show data frame. And you notice this is all new. This capability here is all new, so I can actually look at the whole data. For a data scientist, that's great. And then it also allows me to download that table if I want. So I can download this for using it for something else, for saving it for later, just in case. Notice here, I for this, I archived all of my work. So in any case, we're going to go ahead and do this. And we're going to have it change it over to milliseconds. That's doing the work. Okay, there we go. It's now changed. There's the new table. Look at that. Yuck. Okay, so, but that's how fast it's catching the data. Okay, so now show the time waveform. Okay. Then generate a spectra in linear as amperage. Okay, so an amperage. Nyquist is 2. So that means that it's going to have it. If I don't do the Nyquist, well, actually, let me show you what happens. So generate a spectra in linear as amperage. Show the sample rate and so the sample rate and time applied. Okay, so I'm going to let it do something. So I know that that should be 12 kilohertz. It'll be right around 12 kilohertz. And the sample rate is for about 9 seconds. So let's see what it comes up with. So you notice, here we go. It's doing everything. It's going to show me a time waveform, hopefully. Yeah, that looks about right. And you notice right now it's pausing. That's because it's Sunday, so more and more people are getting up and they're starting to use it. So we'll notice ChatGPT 4.0 is getting more heavy use. Okay, so that's good. This is what I expected to see here. This is a bit of a concern here. But I'm going to do another step and show you how bad this can get. So really, this is not 1.2 times 10 to the 7th amps. So there's things I'll need to do to filter out that peak. It's done something, and that's a bit of an issue. Here I can download the chart. Here I can also download the chart. These are new features. By the way, this feature feature that I'm looking at right here, and the ability to expand the chart. Let's see what it looks like. Yeah, look at that. Those did not exist yesterday. So they keep adding to this stuff. You also notice down here it says ChatGPT can make mistakes. Check important info. Yeah, don't use this for certain outputs. Okay, so it says, here we go. So 12 kilohertz, which is in reality 1248.19, and just over 9 seconds. So it's a little more accurate than I am, and that's because I did this, right? Okay, so interactive charts of this type are not yet supported. So that's going to be something I'm looking into in a little bit. Can I get my interactive chart? That is awesome. That means it's going to be coming soon. Kind of like Plotly. It'll allow me to go in and highlight things and do whatever, I'm sure. That's pretty cool. So anyways, let's get back to this. So convert to a dB spectra where the highest current peak is 0 dB. I'm going to let it do something raw first. Okay. At some point we might run out of number of times. I think unless they've increased it for me, which I believe they might have. When I set it up as a team workspace, because I've got some engineers starting with us soon, then I'm supposed to get more time and more iterations that I can work through. Now, I'm using a paid version. If you're using the free version, certain features don't exist. Okay, so here we go. There's a spectra. So it set it to 0. Oh, good. It did basically. This is what it looks like in the empath. So let's bring it up. Here we go. Resolution. Yeah. Okay. So let's get in here. And did I give it a Nyquist? No. Nope. It came up with its own thing and it set up the dB. Okay, so let's go ahead and let's get rid of some of this stuff, and let's say use redo and use Nyquist, which is a certain thing, Nyquist 2.2. And what do you think? What filter should we use? Let's use round top. Round top. Do we want to do that, or let's what type of filter should we use? Yeah, round top. Okay, let's see what it thinks, and it might yell at me. Now, if I'm not sure what I want to do, okay. If I'm not sure what I want it to do, there's certain other things I can do as well. The other thing too, because it's not going to allow me to. There we go. Wow, it went out to 6 kilohertz, and I lost a lot there, didn't I? That's because of the Nyquist. So let's convert to Nyquist 2. Yeah, it used a low pass Butterworth filter. Don't use that. Okay. Nyquist 2. What else do we want to do? Show graphs with different vibration analysis based filters. So let's go ahead and see what we can do. Now, the next thing I'm going to do is something I haven't tried before, and why not? But as we go through, you'll notice that I'm taking it step by step. It's creating all this. Now, I have often, I'll start up like Anaconda, and I'll go into a Jupyter Notebook. These are all Python tools, or Net, or PyCharm, or Data Spell, or whatever. And okay, so here we go, the different types. Okay, so it's doing band filters. So let's high pass, filtered, frequency, Okay, so let's apply no filters. No filters. Show me different windows. Okay. Okay, so let's see if I just happen to trigger something it didn't like. Oh, no, there it goes. So what I ran into is an error. So that's the other thing is it'll hiccup every once in a while, especially as usage gets more and more interesting. So let's see if we run into any more problems. Okay, let's try this again. Show on different flat top. Why did I call it round top? Graphs, not one for each filter. Okay, so basically it followed my instructions exactly. So those are all different type. But what I really want is each of those filters on a separate graphic. So we could do, say if I'm doing a presentation or a class, and I want to show what each one looks like compared to another. So this is one with a hand window. That's a Hamming window. You don't see a lot of different. That's Blackman window. Okay, and then of course the flat top. So all of them, the bass noise. Okay, so these are a bit lower. Find. Now here's where we're going to go a little more advanced. So you'll notice I'm doing this step by step. Because I've done this enough now, everything I just did, I would normally do in a single command, a single paragraph, to get as much usage out of my time on ChatGPT as possible. I would have said, import the data, filter it this way, do this, show me these, and I could even say, show it because I'm going to use it for this, and by the way, give me these ranges, give me a full spectra, and then zoom in to say 1,000 hertz or 100 hertz or something like that. Now this is my lower resolution spectra data, but you can see I've got a roll off out here. So what was I going to do? See if you can filter out the ground floor noise and show spectra. So I haven't done this before. Let's see what happens. Let's see if it can come up with something for me. So it's okay. It's going to do certain things. Yep. Okay. Filtered noise, filter felt. Amplitude, okay. Ugh, well, okay. It didn't do exactly what I was hoping to. Yeah, so let's go back. We're going to return and use a flat top spectra, Nyquist 2, zoom to 180 hertz. From zoom to 0 to 180 hertz. Show interactive graph. Let's see if it'll do that. Maybe it's something that okay, so it's going to try to do Plotly. Now, if it's not capable of doing Plotly yet, it'll tell me that I have to do this outside. But let's see if it'll do it for me. Okay, it's running. So yeah, part of me is saying it's not going to have Plotly built in yet. As it goes into, there's a web-based database of Python stuff. Okay, yeah. It's doing it again because it's going, yeah, okay, I don't have it. If it starts repeating itself, we'll stop it. Oh, okay. There it goes. And it's still growing in. Oh, okay, this is nice. And there we are. Wow, that is so cool. Look at that. That's my actual frequency. Okay. What frequency is 74 versus this? Okay. Been plotted. Zoomed. Wow. That is cool. Switch to a static chart. Let's go ahead. Let's zoom this out. Let's see what we can do with this. This is kind of cool. So I had no idea. This is probably going to be okay. Yeah, I know what that is, but we're gonna pretend it's something else. So let's see, we've got, what are those peaks? We want to include this peak here, so that is 56 dB down. I think we're looking at about 60 dB. So identify all peaks greater than 60 dB and highlight with a red X, except 0 dB. We don't need that. So let's see if it'll do it. Now I should have asked it to print those out, what those values were, because then I could use the information I know and do some stuff with it. Okay, so let's go back up here. So here we are, 0 dB, and it's really kind of split them out. But we want to leave it where it is. Okay, so there we go. Yeah, it switched it back to the other style. So oh, notice I said greater than 60 dB. Error, big time. So let's go back here, and we're going to change this, and we're going to say greater than minus 60 dB, and redo it. So we'll let it, fix itself. Now, if I had exported that, I could have gone in and just changed the dB value to what I wanted it to. Like it would have had it as 60 dB here. I would have called it the other. So now it's going to mark it up for me. In the meantime, I have this. How does this download? Download the chart. Oh, okay, only as a... I'm going to go ahead and open it. There it is. So we have it as a PNG file. Now I have my stuff here is all in I set it in dark because when you're doing a lot of work and programming and stuff like that, that is usually one of the things we do. It's less stressful on the eyes. So there we go. So here's our frequency, and there's the amplitude. I said greater than minus 60. Why is it giving me all of these peaks? Okay, so it gave me all of these. Oh yeah, because they were. Let's say switch it to greater than minus 50. And you notice that each time I can go through here and rerun it. Basically, I could have done it on the next line down and kept my history and just keep correcting it. Say, hey, you're wrong here. And by the way, yes. So if I were to export this stuff and I put it into Jupyter Notebook and I get an error, I can then highlight that error, toss it back in, and there we go. So here we go. There we go. So there's our peaks, and I can have it listed and everything else, and then I can download this, and then I have them, and because I have them listed, there's things I can do. Let's do one more part of that. Let's say redo and highlight peaks that are equidistant. I have no idea if that's the right spelling, but guess what? It's going to, on either side of the peak at 0 dB and display those values. How valuable is this, right? If I know the peaks I'm looking for, check if there is a one called pole pass frequency if a 6-pole motor is being evaluated, and the RPM is, is about 19 point, oh wait a minute, it would be 18.5 hertz. Okay, so let's see what happens. Okay, so now it's trying to figure out my command. So I put in a little more intense command, and now it's saying, wow, there's more to this. Let me study it, let me think. And of course, with a lot more people coming in, there's the possibility that we will, it'll take a little bit. But now it's chewing through the data. Now, it might be misinterpreting, and it might be looking at the noise as well. It should be remembering that I said less than -50 or greater than -50. Okay. So that was a problem on their end. So just so, I mean, I probably don't have to, but just because. So let's see if it can figure it out now. There it goes, a lot faster. So it basically ran into a glitch. And with all the stuff going on, all the attacks on it and everything else, that's not surprising. Okay, let's see. Will it do it? And then we're going to go into the next step. So these are things you can do with it. There we go. It did not quite get it. So 111 hertz. In this case, no peak. Okay, so it should have highlighted the peaks around it. So there's things that I'll go back in and figure out if I want to do it, that kind of thing. There's ways that I can work with it, but you get the idea. Take it one step at a time when you start, and so on. Now, while we're here, let's go ahead. We're going to get rid of this, and we are going to start a new one. This time, we are going to upload a let's just grab a paper. So this is another thing you can do. So this is a PDF. It's a paper on bearing faults. So review and summarize the uploaded document. Okay, so it gives me who did it and everything else. It's analyzed. It's now giving me the key points. So it's giving me a summary of it. Okay, so is this in vibration or is it in current signature? Okay, great. Using spectral analysis of line current. So it's current signature analysis. Come up with pass-fail values in spectral analysis of current and convert to dB values either down from 0 dB or dB above the noise floor for a ball bearing. Show as show work in math. It's been a long week. So there we go. It's giving me this stuff. It's giving me the formulas I was expecting to see. Okay. Let's come up with that based on the data they provided. So relative noise floor is 20 dB. That's pretty high. Okay, so to a healthy signal level at minus 13 dB, that is really high. Okay, so this is ridiculous. So it's doing an example, but we know, okay, relatively healthy signal, noise floor. So, okay, so it's giving me a 20 dB noise floor. Okay, I see what it's trying to do. So it's working off of their thing, and this is in voltage. Must have been having to do with the paper. So when I take a look at something like this, I'm going, this does not meet my knowledge of current signature analysis. I'm going to have to go in and, I got the paper here somewhere, take a closer look at that paper and see what they're explaining. And my suspicion is this is, not exactly what I'm looking for. So, but it gives me an idea of what their theories are and how to apply it. So that's another way. So let's get on to something else. You know what? Let's do one more thing with this. Change to spectral dB with the peak current at end voltage at 0 dB. Noise floor should be about minus 80 dB. Determine, based on the paper, what the peak above noise floor should be for an alert, not failure, of a degrading bearing, as well as dB down from the peak. Okay, let's see if it comes up with something here. I'm looking for something that should be just a few dB above the noise floor. Did not exceed. Okay, so there we go. So 2 and 6 dB above the noise floor. Okay, so this is what I'm expecting to see. Noise floor is at minus 80. Converting decibels to relative noise floor, 6 to... Okay, so it's showing the work as I had asked it to. So that's actually showing me... it's actually showing me... okay, so 10 dB above the noise floor is a fault frequency. Got it. Now I get it. So, yeah. So basically it's saying at about 2 dB above the noise floor, showing it as minus, it should actually be a positive value. Okay, so if I want to do something yet again, I can do this. Take this chat and convert to a short article. I don't know if it's going to do the reference for the paper. Should. Well, no, it might not. So this is one where I'm taking an existing paper and I'm doing it. I've changed it over and I said write a short article. So it's writing a short article. Okay, there's the summary. Okay, now, because there's formulas in it, this is one of the things I'm going to run into problems with is this right here. If I were to just take this, export it, and print it, or cut and paste it, because I can come up here, well, actually down here, copy it, just this area here, and paste it, this will go wonky. So what I want to do is say, convert article to LaTeX. And what it's going to do is it's going to create the code for something that I could take and put into a LaTeX converter. Let's wait till it's done. I'm going to move this over to a different page, to new window. So I can start up, see what's on there. My LaTeX converter. Oh, overleaf. Yeah, definitely needed to do that. Okay, so I can take this, copy it, and go to something like, here, let's go here, and overleaf, which is a LaTeX converter. We're going to call this a demonstration. I use this for laying out. It used to be the method you'd use for laying out technical papers. Okay, so it is going to not set any type of, so here I could say, you know what, let me just leave it. And we're just going to recompile it. I don't care about this because it's going to be just, there we go. And you can notice the columns are kind of wonky here. So let's go back to my other thing and say redo. Okay. Use 1 inch. That's a word I'm looking for. Space, spacing on the outside. Well, margins. That's the word I'm looking for. Include paper reference. Okay, and then resend it. Now, by the time you view this, by the way, there might be some other features in ChatGPT, but I'm trying to keep it generic. I'm going to show one more thing after we do this, and then that will have exceeded an hour, which is, well, you know, not really my intent. And watching this is almost like watching paint dry, right? But, you know, again, to give you an idea. So it's taking this and it's, let's see if it includes the reference this time on its own. Oh, there it did. It did it. Nice. Okay, so now I can either come up here or down there. And then I could also put in, you know, what I want to have it as as everything else. So let's go ahead and we're going to do it. So back here, I'm just going to get rid of all this stuff, Control V, so I paste in there, recompile, and it's going to show me now with the margins that I was looking for, and I can download it as a PDF, and there's my reference. Okay, so this is actually an IEEE thing. I would want to cite this a little differently, but for purposes of being legit, I want to do that. So the other thing I can do is come in here now. Okay, and then today's date. What is it? It's June 9, 2024. Okay, so let's go ahead and do that. Now, if there's any errors, it will highlight the errors here. So this is actually a really nice one. I think, don't remember if I pay for this one or if it's freebie. There are some freebie latex things, but here we go. So this is basically, now would I put this out as an article? No. I mean, there's a lot of problems with this. This is more like a summary, but we're done. So that's another thing. Now, let's get into some of the stuff that I would do for research. So we found this, and what I want to do is do the same thing, except we're going to do research on existing papers. Now, this here, you'll see this Explore GPTs. There is, and there's probably some brand new ones in here. There are. There's some brand new ones in here. Look at that. You know, you can do all kinds of stuff with Adobe now and all this other stuff in here. And there's DALL-E, the image generator. We'll do that in a future one. There's some really cool stuff I can do there for what I want in presentations and the like. And by now, you're probably seeing a lot of those showing up on LinkedIn and places like that. So here's the one. Now, the one that I am going to stick with for this. Oh, okay, so these are new. I've used this diagrams one, but these are all separately developed, and they are developed. Oh, these are some new ones. Okay, this one I've used. These are all different tools. They're ways that people have used ChatGPT in order to do stuff. So let's go ahead and we're going to go into Ask My Research Assistant. This is one of my favorite ones because it has access to everything, including IEEE papers, right? So it's all technical papers. Research and find articles on determining alarm limits for common findings in motor current, signature analysis, and electrical signature analysis. Okay, so it's going to go and it's going to search that set of databases, and now it's going to come back and give me some stuff. Haven't had that happen before. Don't know why that was. Must have missed stuff. Okay. So this went to a commercial site. So that wasn't very good. Find peer-reviewed technical papers on alarm limits for I guard my site, so my alarm limits didn't show up. MCSA and ESA. Okay, sometimes I just want to make sure that I'm clear because otherwise it might show something else entirely. That's what it did. It did not find it, so in Tech Open, let's see if it finds anything there, then it might skip to something else. So there's not a lot. That's good. That means that when I publish my paper on that topic shortly, then it'll be pretty straightforward. Okay, yeah, went back to yet another technical. Okay, so find peer-reviewed articles on electrical signature. Of gearboxes. Okay, so trying to keep it to the peer-reviewed papers a minute. Okay, so it did kind of say, okay, IEEE Explore and Science Direct. Yeah, great. Let's find some actual papers. Show. Okay, it used to show links. There we go. Let's go to this one. Yeah. There we go. It's playing again. So basically right now I'm not real impressed with that. For some reason it's not doing what it's supposed to do. So let's try something else. Let's try a different approach and say put together a short article on current signature analysis of gearboxes, referencing peer review. Whoop. Okay, so peer-reviewed papers only. It's very important to kind of identify, usually. Okay, so here we go. Ba-ba-ba-bam. Okay, so now here we go. It's identifying stuff. And then I could do the same thing in LaTeX from here. Let's see if it does the references this time. There we go. So here's what I'm looking for. I had to trick it. The other day I would have been able to do the other thing and it would have done this part here where it has the references. So, okay, multi-fault feature detection for multi-stage gearbox. Let's go find that article. So it does exist. Okay, does not look like current signature analysis, though. It's not. Okay, I'm not going to sign in right now. Vibration and signature analysis. So here we go. It's vibration analysis. Let's see if there's a AM, FM vibration signal, sideband characteristics. So I said to do current signature. It decided to do everything except. And this is why you want to check. Okay, let's see what this one is. Electromechanical, MCSA, and some other stuff I'm not familiar with for here. Or they're just calling it something else. Okay, so yeah, interesting. Oh, and it's the whole article. Oh, no, it's not. Okay, just the introduction. You have to. I'm not going to sign into my account, but yeah, it's usually most of these you do. Let's see, that was Science Direct, and again, this one looks more like vibration than it does ESA, but or current signature. But anyways, yeah, this is for demodulation using vibration analysis. Again, this is some of the stuff we warn about, is do not rely on this stuff. But does that mean I couldn't do what I just did earlier and take that data and then say, hey, let's explore how to evaluate this with current signature and so on. So there's ways of doing that stuff. Let's see. Let's do one more quick thing here to end our day. We're going to delete that. we're going to go back to a regular ChatGPT. We're going to come here. We're going to import something. Let's see a few things that I did recently. Let's take these. Okay. Review the attached papers that I've written. This is important. And generate a single article related to the data contained, and develop and use the contained data to provide an example. Okay, so there's one more that I want to do after this, and there's a reason for that. So, okay, here we go. So this is this has to do with some hydro stuff. So here we go. Yeah, so it took the data and it said, let's go ahead and create an article associated with the data, and so on and so on and so on. And then I can convert this over to an article. But the key thing is that I have to say article that I created, so it doesn't say, nope, can't do anything with it. So it'll look and see that that I have certain things. So, okay, so let's get rid of this one. And last thing we want to do, let's go ahead and we are going to upload I didn't really prep for this one. Images. Let's see if I can find a. Okay. Okay, so we're going to upload an image of something. We're going to describe it. Describe what is in the image if the center is of a rotor winding and a stator winding. Okay, so let's see what it thinks it sees. And it's going to go back out. Insulation materials and wear. It's seen this, and near the bottom left there are signs of damage such as burned or melted insulation, electrical failure, overheating. Okay, so yeah, so it said it sees certain things. I know this is a catastrophic failure. So it's not quite there yet. Look into articles and papers written by Howard Penrose in Motor Doc AI, Motor Doc LLC, and see what might have caused this rotor damage. I have no idea what this is going to do. I just thought I'd have a little fun here. And while I have an audience, right? As you can see, there's a lot of interesting things. Okay, so here we go. Thermal cycling, electrical discharges, manufacturing defects, operational stresses. Yeah, it's putting me into, let's go take a look Okay, article I wrote for Reliability Connect some time ago. Okay. Yeah, it just talks about it. Okay, so in effect, that really what we were looking at there is a rotor connection failure. So, but it's interesting that did this. I had no idea. That's new. I mean, and some of the features and how this did that's relatively new stuff. So in any case, that will end it today. In next week, what I'm going to do is I'm going to show you how to utilize 4.0, or if 5's released by then, but one of them. We're going to walk through a ProAct analysis of a real machine next week, assuming I get a chance, the next episode. So that's it for today. Watch for the newsletter. It'll be coming out later this week because I want to wait for that other interview to come out. There's going to be a lot of papers, a lot of other stuff. I've been falling behind on everything. We've been super, super busy. Hence, I'm working today. I'm going to be analyzing a bunch of turbines. But for now, because it's a beautiful day outside, I'm going to get in a quick walk before I sit in front of the computer for the rest of the day. So with that, be safe and have fun.